Now, let's have another example here. Same thing as what we have earlier. The list is just the same. It's just that the target value is changed from 6 to 103. So again, how are we going to justify that 103 is not within the list? So again, we're going to get the first, the last, the mid, and compare the values within the list and the target value. So again, we are going to start it at first is 0 and the last position is 9. Again, test the first if less than or equals to last. If it's true, then get the mid. Then compare the value. So our target is 103. That is greater than to 19. So again, if it's greater than to 19, I'm going to highlight this portion, and this portion is the upper half. So that means 103 can be found at the upper half portion since 19 is less than 103. So in this case, we're going to change the first position. The last position is still the 9, but the first position will be mid plus 1. Mid plus 1 means 4 plus 1, and the first position this time is at position 5. Then again, test the first if it's less than or equals to mid. If it's true, then you add. So 5 plus 9 is 14 divided by 2, that is 7. So 7 is 78. Again, 103 is greater than 278. So in that case, we're going to get the upper half portion. And the upper half portion is this on the green highlight. So again, we're going to change the value of the first, not the last. Last is still 9. So to get the first position, again, we are going to add the middle, which is 7 plus 1. So that is 8. So again, test the first and the mid if it's less than or equal. So 8 is less than or equals to 9, then we can get the mid. Again, getting the mid is first plus last divided by 2. So that is 17 divided by 2, that is 8. Okay, so from 8, that is 102. Still, 103 is greater than 102. Okay, and that's the case. Again, we're going to look at the upper half. So this is the only upper half now. Okay, so again, we are not going to change the last position, but we're going to change the first position by adding the mid by 1. So this becomes 9. Then again, test the first if less than or equals to last. So 9 is less than or equals to last. That's true. So we can get the middle element still. So 9 plus 9 is 18 divided by 2 is still 9. So 9 is the last one or the last value that we can actually compare. So in this case, this is 103. This time it is less than 114. So if that is less than 114, we are going to change the first. We're going to change the last position but not the first. So this becomes so again, since 103 is less than 114, we're going to look at the lower half. But again, we already get the lower half. So what we're going to do here is just change the value of the first. So how are we going to get the value? We're not going to change the value of the first. This is 9 still, but we're going to change the value of the last. Since we are talking about less than, it means we're going to get the lower half. Again, if we're getting the lower half, we change the last. If we're going to get the upper half, we always change the first. So please take note of that. Okay. So in this case, by changing the last element, we are going to get the last equals to mid minus 1, and that is 8. So in this case, once we repeat the process of comparing the first, if it's equals to or less than or equals to the last, is 9 less than or equals to 8, that is false. That means we are going to stop the loop. And that means we do not found the value of 103. But again, our final first is equals to position 9. Our final last here is equals also to position 8. And the final mid. So this is the final mid, the last simulations the last simulation that we did, and that is equals to 9. So in this case, found equals false, meaning we do not found the item 103 within the list.